Good morning, friends. Today we are going to discuss about pilot control and speed control of a single acting cylinder. So, friends, this is the arrangement of a single acting cylinder. So, that is here. Now, firstly, we are going to discuss about speed control of a single acting cylinder. So, friends, in this class, I would like to take, two topics. So, the first one is speed control of single acting cylinder, and the second item is pilot control of single acting cylinder. So, friends, this is the figure which indicates the general arrangement for speed control of a single acting cylinder. So here we can see the arrangement of flow regulator. So this is the most important item so far as speed control is concerned, and this is called as a flow regulator. Also, it is referred to as speed regulator. So, friends, while operating the circuit, so we have to control the quantity of fluid that is entering the cylinder. So this flow regulator will be controlling the quantity of fluid that is entering the cylinder. So therefore, it is called as flow regulator. And secondly, by regulating the quantity of fluid, ultimately it will be regulating the speed of the fluid that is entering the cylinder. So therefore, it is also called as speed regulator. And secondly, by regulating the speed of the fluid that is entering the cylinder, we can regulate the speed of the piston that is moving inside the cylinder. So therefore, we have to make use of this item. So it is basically controlling the quantity of fluid that is entering the cylinder. So therefore, it is called as flow regulator. And by controlling the quantity of fluid that is entering the cylinder, it will be controlling the speed of the fluid and thereby it will be controlling the speed of the piston which is moving inside the cylinder. So friends, therefore, this is also called as speed regulator. So friends, basically it is controlling the quantity of fluid. So that is entering the circuit or cylinder. So that's why it is called as a flow regulator. And by controlling the quantity of fluid, it is controlling the speed of the fluid and also the speed of the piston that is moving inside the cylinder. So therefore, it is also called as, speed regulator. So friends, regulating of quantity of fluid and also controlling the speed of the fluid, that is very, very, important for operating the circuit. So therefore, it is referred to as speed control of the cylinder. So friends, as far as this topic is concerned, so this is the main component, main item to be placed in the circuit, so called as flow regulator, and also it is also referred to as, speed regulator. And secondly, this flow regulator, it is divided into two components. So consisting of throttle valve placed in the left-hand side portion, and secondly, a check valve that is placed in the right-hand side portion. So friends, flow regulators are divided into two components. So flow regulators will be consisting of two valves. So the first one called as a throttle valve, and the second one referred to as a check valve. And secondly, friends, this throttle valve, as far as this circuit is concerned, so this throttle valve will be controlling the quantity of fluid that is entering the cylinder, and finally the check valve will be receiving the total quantity of fluid that is coming out of the cylinder. So friends, throttle valve here in this particular arrangement, the throttle valve is used for sending fluid during the forward stroke of the piston, and check valve is used for receiving the fluid during the return stroke of the piston. So friends, this is about the arrangement and purpose of throttle valves and check valves. Now, as shown in the figure, the check valve is placed in reverse position, reverse direction. So therefore, it is used only for receiving the fluid that is coming out of the cylinder. So therefore, throttle valve in this arrangement, throttle valve is used for sending the fluid into the cylinder. So friends, these are the components of flow regulator. The first component called as throttle valve. So in this arrangement, this throttle valve is used for sending the fluid into the cylinder. And the second component called as check valve, so that is placed in reverse position. So therefore, it is used for receiving the fluid that is coming out of the cylinder. So friends, throttle valve for sending the fluid and check valve for receiving the fluid that is coming out of the cylinder. And finally, both these components put together, both these valves put together, it is referred to as a flow regulator or speed regulator. So basically, this item is controlling the quantity of fluid, therefore it's called as a flow regulator. And by controlling the quantity of fluid, it is controlling the speed of the fluid and also the speed of the piston that is moving inside the cylinder. So therefore, this is also referred to as a speed regulator. So friends, this is about the arrangement of a flow regulator. So used for controlling the operation of a single acting cylinder as shown in this particular circuit diagram. And finally, friends, we can see the inlet of the regulator. It is placed in the bottom portion, and here we have the outlet of the regulator. Now, as usual, the inlet of the regulator is connected to the pipeline that is coming from the outlet of the DC valve. And finally, the outlet of the regulator is fitted to the pipeline that is entering the port of the cylinder. So friends, basically this is called as a system pipeline divided into, different components or different, branches. So initially the system pipeline will be sending the fluid from the DC valve to the flow regulator. And finally, it will be sending the fluid from the flow regulator into the single acting cylinder. So this is the arrangement of these pipelines used for conveying fluid from DC valve into the air cylinder, and also from the air cylinder into the DC valve. So friends, this is the arrangement of system pipeline, and as already discussed, this flow regulator will be placed in between the DC valve and the cylinder for operation of the circuit. And friends, finally, we have, we can see the arrangement of branch pipelines inside the flow regulator. So first pipeline used for connecting throttle valve with the single acting cylinder and the DC valve, and second pipeline for connecting the check valve with the single acting cylinder and the DC valve. So friends, four pipelines, four branches are actually arranged in this particular circuit. So the first pipeline for conveying the fluid from the DC valve into the regulator, and second pipeline will be conveying fluid in between the regulator and the cylinder, and third and fourth pipelines they are used for connecting this throttle valve and check valve with the DC valve, and also the cylinder that is used for operating the circuit. So friends, this is the main purpose and this is the general arrangement of a flow regulator, which is also referred to as speed regulator. So consisting of two valves. The first one called as a throttle valve for sending fluid into the cylinder. The second one called as check valve placed in reverse direction for receiving the fluid that is coming out of the cylinder. So this is the arrangement of throttle valve and check valve. So used for controlling the speed of the piston. So therefore, this circuit it is referred to as a speed control of a single acting cylinder. Now, friends, coming to the other components, as usual, the single acting cylinder fluid will be acting only on one side of the piston. So it will be entering and leaving from the hand side of the piston. So therefore, it's called as a single acting cylinder. And one port is sufficient that is made in the left hand side of the piston. So that is used for sending the fluid, not only for sending the fluid into the cylinder, but also for receiving the fluid that is coming out of the cylinder. And friends, finally, we can see the arrangement of a return spring. So in the case of a single acting cylinder, always, fluid pressure is used for performing forward stroke of the piston. And spring pressure must be used for performing return stroke of the piston. So therefore, this return spring, it is arranged inside the single acting cylinder. So friends, as usual, the piston is fitted to the piston rod as shown in the figure. And finally, the piston rod will be connected to the tool of the machine. So with this arrangement, this cylinder can be used for moving the machine tool in forward and backward directions. That means when the piston moves in forward direction, naturally the tool will be also moving in forward direction. And when the piston moves in reverse direction, naturally the tool will be also moving in reverse direction. So friends, this is about the speed control of a single acting cylinder. So now we can see the arrangement. Let us make a note of all these items. So here we can see the arrangement of the DC valve. So that is placed before the flow regulator. So three ports are made inside the DC valve. So one inlet port and one outlet port and one exhaust port as shown in the figure. So it's called as a three-way valve. And the push button is placed in this region and the return spring is placed in this region. So push button is used for moving the valve element, that is the plunger, in reverse direction. So when the plunger moves in reverse direction, valve will be coming to first position. And if the push button is released by virtue of spring action, the plunger will be moving in forward direction. And therefore the valve will be coming to second position. So friends, just like any other circuit, we have talked about number of circuits pertaining to this subject. So in any circuit, first position of the DC valve will be used for sending the fluid and performing the forward stroke of the piston. And second position of the DC valve will be used for receiving the fluid and performing the return stroke of the piston. So friends, this is the arrangement of the DC valve. So the inlet of the valve is connected to the pipeline coming from the compressor, and the outlet of the valve is fitted to the inlet of the regulator. And obviously, the exhaust port of the DC valve is fitted to the pipeline that is entering the atmosphere. So air coming out of the circuit will be, making, lot of producing lot of sound and noise. Therefore, mufflers exhaust pipelines are covered by means of mufflers for reducing the sound intensity of fluids. So friends, the mufflers are not required for operating hydraulic circuits, but for operating a pneumatic circuit, we'll be using high pressure air, and that will be making, generating lot of, lots of amount of sound intensity or, noise levels. So for reducing the, sound intensity of the fluid, generally the exhaust pipes of pneumatic circuits, they are fitted with mufflers. So friends, this is the arrangement of this circuit. And friends, we can see the arrangement of the compressor. So driven by an electric motor. So if you switch on the motor will be converting electrical energy into mechanical energy. And in the second stage, the compressor will be converting the mechanical energy of the shaft into pressure energy of fluid. So friends, hydraulic pumps are used in hydraulic circuits. Hydraulic pumps are used for generating pressure energy of oil. And here in the case of pneumatic circuits, compressors are used for generating the pressure energy of air. So friends, compressor is the vital component of pneumatic circuit. So used for generating high pressure air, and high pressure air coming out of the compressor is stored in this reservoir. It's called as air receiver. And finally the fluid that is stored in this reservoir is ultimately used for operating piston that is arranged inside the cylinder. And friends, here we can see the arrangement of FRL unit. So filter for removing impurities present in the fluid, and a regulator for controlling the pressure of the fluid that is entering the circuit, and a lubricator for sending lubricating oil or for lubricating the piston that is moving inside the cylinder. So friends, filter, regulator and lubricator must be placed in this particular order. The first stage, filter is placed in the first position, regulator in the second position, and lubricator in the third position. So all these items, they are made in the form of a single unit. It's called as a FRL unit, and they are used for increasing the efficiency of the compressor. So therefore, they are referred to as accessories of the compressor. So friends, we can see all these items very essential for controlling the speed of single acting cylinder. So we have identified all the elements, the arrangement of the compressor, the arrangement of the reservoir, and arrangement of FRL unit, arrangement of DC valve, arrangement of single acting cylinder, the arrangement and above all arrangement of flow regulator in between the DC valve and single acting cylinder. So friends, as a whole, flow regulators will be controlling the quantity of fluid and thereby the flow regulators will be controlling the speed of the fluid. So therefore, they are on one hand, they are referred to as the flow regulators, and on other hand, they are also referred to as speed regulators. So friends, by regulating the quantity of fluid, it is regulating the speed of the fluid that is entering the circuit. Therefore, it is referred to as a flow regulator, and also, they are referred to as speed regulators. So friends, we have talked about the purpose and arrangement of flow regulator consisting of two valves, and in this arrangement the throttle valve is used for sending the fluid into the cylinder, and the check valve is used for receiving the fluid that is coming out of the cylinder. So friends, this is the arrangement of a flow regulator that is generally used for controlling the speed of single acting cylinders. So friends, you can once again you can have a look at all these items, arrangement of various elements required for operating the circuit. So this is called as speed control of a single acting cylinder. So friends, we have completed the study of speed control of the cylinder. So now in this phase, we are going to talk about the pilot control of a single acting cylinder. So also called as indirect control of the cylinder. So friends, as the name itself implies, we can see the arrangement of a pilot valve and the arrangement of a DC valve, and finally the arrangement of a single acting cylinder. So initially the pilot valve will be controlling the action of the DC valve, and finally the DC valve will be controlling the operation of the cylinder. So if not directly, indirectly, this pilot valve is ultimately used for controlling the operation of the cylinder. Therefore, it is called as indirect control of the cylinder, and we are using a pilot valve for doing this control. So therefore, it is also referred to as a pilot control of the cylinder. So friends, this is the arrangement of this particular circuit. So here firstly we can see the arrangement of a pilot valve. So three ports are made inside the body of the pilot valve. So therefore it is referred to as a three-way valve. And a push button is used for operating the plunger of the pilot valve. So therefore it is referred to as push button pilot valve. Also it's referred to as a push button three-way valve. And friends, here, this exhaust port is placed in this particular region. So therefore, push button must be placed in the right hand side portion, and spring, return spring must be placed in the left hand side portion. So with the arrangement of ports in this particular fashion, push button has to be placed in the right hand side, right side of the pilot valve, and similarly return spring has to be placed in the left side of the pilot valve. So friends, as usual, this push button will be fitted to the plunger that is arranged inside the body of the valve. So therefore, push button will be moving the plunger in reverse direction, or putting the valve in first position. And in the second phase, it will be releasing force on the plunger. So therefore, by virtue of spring pressure, by virtue of spring action, element will be moving in forward direction. Ultimately, it will be coming to second position. So friends, in any case, push button is used for putting the valve in first position, and return spring will be used for putting the valve in second position. And friends, as usual, the first position of the pilot valve, it is ultimately used for performing the forward stroke of the piston, and second position of the valve is used for performing the return stroke of the piston. So friends, this is the arrangement of a pilot valve. So that is mainly used, basically used for controlling the DC valve, which is ultimately used for controlling the operation of the cylinder. So friends, this is the arrangement of the pilot valve, and the inlet of the valve is fitted to the pipeline coming from the compressor, and outlet of the pilot valve is fitted to the left hand side of the DC valve, and finally the exhaust of the pilot valve, it is fitted to the pipeline that is entering the atmosphere. So friends, this is the about the arrangement of a pilot valve that is ultimately used for controlling this single active cylinder. So therefore, it is referred to as pilot control of the cylinder. So though not directly, indirectly, it's a pilot valve is ultimately it is controlling the action of the cylinder. So therefore, it is also referred to as indirect control of the cylinder. And friends, we can see the arrangement of the DC valve. So in the case of DC valve also, I mean, 3 ports are made inside the DC valve. So therefore it's also referred to as a 3-way valve. So consisting of one inlet port that is fitted to the pipeline, again coming from the compressor, and the outlet of the DC valve, it is fitted to the pipeline which is entering the port of the cylinder, and finally the exhaust port is fitted to the pipeline that is entering the atmosphere. So friends, just like pilot valve, which is also provided with, I mean, 3 ports. So therefore, it is referred to as a 3-way valve. And finally, friends, 2-way valves and 3-way valves are provided with only one outlet. So therefore, they are only suitable for controlling single acting cylinders as shown in the figure. And on the other hand, 4-way and 5-way valves are provided with 2 outlets. So therefore, they are used for controlling the action of double acting cylinders. So friends, in any case, only 2-way and 3-way valves are only suitable for controlling single acting cylinders. And 4-way and 5-way valves are only suitable for controlling double acting cylinders. So friends, I mean, this is the arrangement of 3-way valves. I mean, used ultimately for controlling the operation of the single acting cylinder. And secondly, friends, as usual, an element is placed, a plunger will be placed, a spring-loaded plunger will be placed inside the, I mean, body of the valve. And here, compressed air or high-pressure fluid coming from the pilot valve that will be used for moving the plunger in forward direction. So as a result, valve will be coming to first position. And in the second phase of operation, supply of fluid is cut off from the pilot valve into the DC valve. So therefore, by virtue of spring action, plunger moves in reverse direction, and the valve will be coming to second position. So my dear friends, here so far as a DC valve is concerned, I mean, fluid is used, fluid pressure is used for putting the valve in first position, and spring pressure is used for putting the valve in second position. And similarly, friends, so far as a pilot valve is concerned, push button is used for putting the valve in first position, and spring pressure will be used for putting the valve in second position. So friends, I mean, this is the general arrangement of the circuit, and the first phase of operation, the pilot valve will be coming to first position, and it will be sending fluid into the DC valve. So as a result, the DC valve will be coming to first position, and it will be sending fluid into the cylinder, and this is used for performing the forward stroke of the piston. And friends, in the second phase of operation, the pilot valve will be coming to second position, and therefore the supply of fluid is cut off into the DC valve. So therefore, by virtue of spring action, the plunger comes back to the initial position, And as a result, the valve will be coming to, this DC valve will be also coming to second position. And friends, when the DC valve comes to second position, supply of fluid is cut off into the cylinder. As a result, by virtue of spring action, the piston moves in reverse direction. And this is called as a return stroke of the piston. So friends, this is circuit operation. It is divided into two phases. So in the first phase of operation, the pilot valve will be coming to first position and it will be placing the DC valve in first position. That is used for performing the forward stroke of the piston. And in the second phase of operation, the pilot valve comes to, second position, and thereby it will be putting the DC valve in second position, and that is used for performing the return stroke of the piston. So, friends, here this is the arrangement of this so far as control of cylinder is concerned. So pilot valve is ultimately, controlling the action of the cylinder. That's why it's called as pilot control of the cylinder. And if not directly, indirectly, it is controlling the action of the cylinder. So therefore, it is also referred to as indirect control of the cylinder. So friends, this is the arrangement of circuit so far as indirect control of single acting cylinder is concerned. And friends, we can see the arrangement of compressor and FRL units and all that. So these items are very, very essential for operating all the circuits. So we can see the arrangement of all these items in the bottom portion of the circuit diagram. And friends, let us have a look at the pipelines. So different pipelines are very, very essential for joining different components of the circuit. So this is the first supply pipeline. So used for connecting the compressor and the pilot valve. And this is the second supply pipeline for connecting the compressor and the DC valve. So this compressor will be sending fluid into the DC valve for operating the element of the piston. So therefore it is called as primary fluid. And at the same time, this compressor will be also sending fluid into the pilot valve for operating the element of the DC valve. So this is called as secondary fluid. So friends, we have discussed about the primary and secondary fluids in many sessions. So primary fluid is used for controlling the element of the cylinder called as a piston. Secondary fluids are used for operating the elements of DC valves. So friends, we can see the arrangement of this supply pipelines. So first pipeline for sending the primary fluid into the DC valve, and second pipeline for second supply pipeline for sending secondary fluid into the pilot valve. So friends, this is the arrangement of supply pipelines. So far as this particular circuit is concerned. And secondly, we can see the arrangement of the system pipeline. So this pipeline is used for connecting the outlet of the DC valve and the port of the cylinder. So therefore, it is referred to as a system pipeline. And here we can see the exhaust ports of a pilot valve and DC valve. So they are connected to the pipelines, I mean, entering the atmosphere. So therefore, they are referred to as exhaust pipelines. And finally, this pipeline is used for supplying fluid in between the pilot valve and the DC valve. So therefore, that is referred to as a pilot pipeline. So friends, for operating this particular circuit, so two supply pipelines are essential for operating the circuit. So we can see the arrangement of two supply pipelines, two exhaust pipelines, one system pipeline, and one pilot pipeline. So, friends, totally, I mean, six different pipelines are used for connecting the, I mean, elements of all the elements of this circuit. So all these pipelines, put together, it is referred to as a piping system. And friends, we can see the positions of these two, I mean, valves, positions of pilot valve and DC valves. So in the first phase of operation, both the valves will be in first position as shown in the second figure. That is used for performing the forward stroke of the piston. And in the second phase of operation, both the valves will be in second position as shown in the first figure. That is used for performing the return stroke of the piston. So friends, just now we have talked about the positions of pilot valve and DC valve. So first positions required for forward stroke of the piston, and second positions required for performing return strokes of the piston. So friends, the second figure is indicating here in this particular slide, the second figure is indicating the first position of both the valves, essential for forward stroke of the piston. Second figure, it is indicating the first positions of valves essential for forward stroke of the piston. And first figure, it is indicating the second positions of valves essential for return stroke of the piston. So finally, friends, this is about the arrangement so far as indirect control of single acting cylinders are concerned. So friends, in the first phase of the session, we have discussed about the speed control of single acting cylinder. And finally here we have discussed about the pilot control of single acting cylinder. So friends, thank you so much for joining the session.